The learning of skills on the human level is a complex process which is only partly understood. For instance, we know that acquiring a skill like diving involves imitation of others and trial and error practice. We know, too, that humans are aided in their learning by ability to verbalize and by superior powers of remembering and reasoning. But we do not yet know the precise answers to such questions as, what do we actually learn, and how does learning actually take place? The reason for these unanswered questions is that the human organism is the most complex in the entire animal kingdom. Only in very young children can we find human learning reasonably free of such complicating factors as emotional attitudes, the capacity to reason, and already acquired knowledges and skills. But for obviously humane reasons, research with small children cannot be pursued too strenuously. By experiments with pigeons under controlled laboratory conditions, we can more conveniently study the intricacies of the learning process. For our experiments, we shall use this box, the top and 3 walls of which are glass. The back wall has a food trough where the pigeon can be reinforced with food. Above the food trough is a disc that can be made to appear either white or black. In these experiments, we shall use pigeons that are very hungry. Food is therefore a strong reinforcement which we can use in shaping their behavior. Our first pigeon pecks the disc. A response which he has previously learned brings reinforcement in the form of food, regardless of whether the disc is white or black. The bird does not discriminate between black and white discs. Now we flip a switch at the back of the box which will change the mechanism so that he gets paid for pecking only if the disc is white. At first, he doesn't catch on to the new working conditions and goes on for a while pecking hopefully at both colors. The reinforcement, however, comes only when he pecks on white. Seven minutes later, by the clock, our bird pecks only when the disc is white. He has learned that when he sees the white disc, the pecking response gets reinforced, and when he sees the black disc, the same pecking response does not get reinforced. He therefore stops pecking when the disc is black and pecks only when the disc is white. This ability to discriminate between stimuli, to respond by pecking only the color associated with reinforcement, is called stimulus discrimination. This process of stimulus discrimination appears to be a basic part of all learning by humans as well as animals. Take, for example, the human response to traffic lights. We learn that, generally speaking, the response of moving a vehicle forward is more satisfying when the light is green than when it is red. This is the same kind of stimulus discrimination as our pigeon developed, to stop on one color, to go on another. Now let's return to our experiment box and watch another pigeon learning a different type of stimulus discrimination. This pigeon has been trained to discriminate between silence and a certain sound. First, when he hears nothing, he doesn't peck. He pecks only when he hears the bell. This kind of discrimination between silence and a certain sound is so common in everyday experience, we hardly think of it as a learned skill, which it really is. Here is another pigeon whose discrimination is even more refined. While one bell sound is heard, he shows no response at all. But the instant the bell sound pattern changes, our friend comes running for dinner. To see the same kind of stimulus discrimination on the human level, go to any firehouse. This fire alarm signal is not for him. But suddenly the signal comes for his own district. The response is definite and immediate. We can train our pigeon to discriminate between different tempos of the same sound. The slow tempo of the metronome brings no pecking response in him. But when the tempo is speeded up, there is a rush for the disc, for he has learned that in the presence of this stimulus, the pecking response will get paid off. While this scientist's Geiger counter clicks at one speed, he ignores it. But a faster tempo of clicks brings immediate response, for he knows that he's supposed to do some specific thing whenever he hears this different sound stimulus. All these behavior examples we have seen thus far in this film illustrate the process of stimulus discrimination, making a particular response depend upon the presence of a particular stimulus. This is one basic part of all learning. To demonstrate another major element in learning, response differentiation, we return once again to the pigeon. For these experiments, the pigeon will still get his food in the same trough, but there is no disc for him to peck. Instead, release of food into the trough will now be controlled completely by a manually operated electric push button. As this button is pushed, the food tray comes up and a buzzer sounds. At the same time, a white light shines inside the trough. The light and buzzer together become the signal to the bird that food is accessible. Now we're going to train our pigeon to make a complete turn clockwise. It's the old getting warm game. Every time he turns a little further, he gets paid. He made another quarter turn and is reinforced again. Go on, a little further. Very good. He's reached the halfway mark. Go on around. No, wrong way. All right, there's one, just to keep him going. And now, all the way around. Good, he made it. One on the house, just for insurance. Now, has he really learned his lesson? There's no doubt about it. Our pigeon has acquired clockwise turns. And even double turns. Through a process of trial and error, the pigeon finds the response that brings satisfaction of his hunger, and then concentrates on that response, gradually eliminating other responses. This process is called response differentiation. It too appears to be a basic part of all learning. Now, let's watch an example of this process on the human level. The mother of this child knows he is thirsty. Before giving him water, however, she is trying to get him to ask for it by its correct name.
Wayne, say water.
By repeating the word water, Mother creates a stimulus involving the sound of the word and the sight of her lips.
Say water.
However, the dominant stimulus appears to be the sight of the water cup, and the child responds merely by reaching for it. But this response is not reinforced with a drink.
Say water.
Gradually, the child begins to discriminate the stimulus of Mother's repetition of the word water.
Say water.
And to differentiate out the wrong, unproductive responses, such as reaching for the cup and uttering meaningless sounds.
Wayne, say water. Water.
When finally the child responds with the word, he gets reinforced in two ways.
That's the good boy.
Mother gives him the water along with praise for his accomplishment. Next time, Mother will again withhold the water and the praise until the child says the word water. Thus, through the processes of stimulus discrimination and response differentiation, the child learns to say the word water. This process of refining the response in order to gain satisfaction appears to be basic to progressing from beginner to any degree of expertness throughout the entire range of human skills, whether it be in a hobby or in a vocation, in personal care or in communication, sports activities, or any other skill. Regardless of what the skill may be, efficiency in learning is accomplished to the degree that useless or distracting stimuli can be ignored and unproductive responses eliminated. We can readily appreciate the complexity of the learning process and the tremendous range of its application when we consider that the human organism can start with this maneuver as a baby, improve to this maneuver as a small child, and finally develop a skill to this level of achievement.